Thank you. So this is the last presentation of the conference. And the idea with this conference is to give you the context, exactly why we're doing this project, and CrossMiner, for instance, in particular CrossMiner, is to be able to provide tools that can help our projects position themselves in terms of readiness with regard to the market out there. And in the market out there, in fact, it's not just your next door or your developer friends who's an IT professional like you are, and who can maybe feel very comfortable with what you're developing. No, the market out there is the average decision maker. So what we're thinking of is the conventional decision maker who's never heard of open source, who's probably more comfortable with buying proprietary software, and who might feel that open source can be evil and has heard that open source is not right, etc., etc. So we won't say, no, this piece of open source code is right, you can go for it. So that's the idea. And the thing is, between the developer and that user I've just talked about, there is quite a distance, quite a great distance. It's not like selling or showing the piece of code or debugging it online as we've seen this morning, but it's really a question of reaching out to somebody who might not be a developer at all, not an IT person at all. And for these persons, what the developer does is not something they can use. For the layman, I don't know if you are musicians here in the room, but code is a bit like this. This is not complete. When you have this, you only have part of the story. And the average decision maker doesn't want that. What the average decision maker is this. What you've just heard is what you could see on the screen. The final product, what has value, is not just the code, is something that has code, like this, text, but also a whole sort of things that create the actual market value. And talking about software, it means documentation. For you, it's basic. It's been something that has been tested. It means something that have a plan for upgrades, bug fixing, training, packaging, case studies, collateral, pricing, contracts, even other users. I mean, as an average decision maker, I feel comfortable in the company of other users. I don't want to be the first one, etc. Especially with your open source software, they want a sense of predictability. Where is this project going? A sense of quality. Can we trust? That's what we want to, the kind of need these customers have. So research and development does what you have on the left, and what the customer wants, the customer is completely on the other right, and the gap between is what we use, you call at OW2 the delivery challenge. This delivery challenge is usually covered, addressed by the ecosystem. Not just the developers, but distributors, systems integrators, communities, contributors, and open source organizations. We are part of the ecosystem. And other users that can share experience, best practices. That's what the average, and I'm talking the average decision maker, want. So we want to give them the elements, the data, the arguments, the resources to decide in confidence. The idea is really that one architect can tell his or her manager that they are using this piece or that piece of open source software for a reason, and that it's okay. No need to worry. No worries. In fact, there is an analogy in what we do in IT. It's the analogy of the car industry. You know, the car manufacturers, don't manufacture half of the cars. They assemble components. Entire parts, pieces of the cars come from third-party providers. The whole dashboard, the whole front of the car, including with the lights. These are blocks that come together, huge components. The whole seats, the leather, the whatever, that is provided by third-party. Everything, all the windows, everything that glass is provided by third-party providers. A car manufacturer today does not manufacture a car. A car manufacturer today conceives a car. A car manufacturer today offers the car that meets the needs of a segment. That's what they do. And they have the marketing and the financing and the delivery and the network, etc. So that's what we do in IT. When we develop code, we don't develop code. We assemble most of it. This is a stats from Sonotype, an analysis of over 2,000 developers that shows that 80 to 90% of a typical application is composed of components. These components, many of them, we think, are open source components. I would say probably majority of them. I don't know exactly, but let's assume that they are open source components. And what we want to help the average architect who's going to build an application by selecting a project from OW2 to be able to tell his or her manager that their selection, that choice is safe. We want to make them easy to select. And we're not the only one addressing this need. I mean, metrics, knowing what's in a component, it's something that has been around for some time. When we started thinking about that 6 years ago, we realized there were many projects. So Assad mentioned OSS meter, we were part in RISCOS, there was now CrossMiner, of course, is part of this, and then there are a number of initiatives, all aiming at understanding what's in components, where they go. And it's true that we use platforms, we use development environments that generate a huge amount of data. We can grab this data, make sense out of it. The question is, we have done that already. We've set up OSCAR, that I already introduced a couple of times, which is both a methodology and a platform to grab information. And we can publish a lot of information. We have information, you can look at the dashboard of each project, or OW2 project, and they have a dashboard with a lot of data. Data from all the tools we use, data and information covering licenses, communities, quality, the code, etc. But then, it's presented like this. You have to make sense out of that. What we think is that the average decision maker does not want to look at these charts. The average decision maker wants something like that, a scale. Is this thing okay for me, or is it just half-baked and useless for me? And when we were thinking of that, we had a very easy example to follow. That from the NASA, the technology readiness levels. The technology readiness levels is a type of measurement systems just to evaluate the maturity of a particular technology with some rules, and they define a certain numbers, and it's been found useful. It's been reused by the DoD, the Department of Energy as well, and now it's something you see in every proposal of projects submitted to the European Commission. Thing is, that's what the NASA DoD technology readiness actually looks like. At the bottom, you have the thing that is useless. There are the basic principles observed and reported. Then halfway, you have the test, the trials in more and more realistic conditions. And then at the top, you have the level reached by the thing that went around the Earth and came back if it had to come back. So we thought, for the average decision